Last week we dealt with algorithms. Algorithms is the leading source into actual programming. If you do not know how to do an algorithm correctly, and what is an algorithm? Yes, an algorithm is a step-by-step tool used to create the steps leading into a programming source. So, as we go today, we are actually going to talk about the computer systems, the simple programming logic going in to a program, the steps involved in the development cycle, and we will actually touch base with the pseudocode, symbol value, and the other two tomorrow. So, as we dealt with algorithms, algorithms is a step-by-step tool used, kind of like a step-by-step, think of algebra. What are the steps it takes to produce a certain result from an equation? That's like an algorithm. Well, the same thing here, we're going into computers now. Computers uses an algorithm. An algorithm is a step-by-step approach. So, when we talk about the computers leading into programming, we have the computer system. Computer system is a combination of all the components required to process and store data used in a computer. So, you have the computer system. The computer system is right there. The computer system is made up of all that. Then you have the hardware. The hardware is what encompasses the computer system. That is the equipment. Your printer, your computer. You got to know what the computer is before you can actually program the computer. Software, that's where we're going to now. We're leading from the hardware that we were at into the programming. The programming is the software. What is it that we're going to create for the user? Who's the user? The user could be you, could be your friend, could be me. The user is the person that will use the program after you finish it. So what is software? It's nothing but computer instructions. It tells the computer what to do. Remember I said, computers only understands binary code, ones and zeros. Doesn't know what to do. So we have to tell it what to do. Then that's why we created a program. A program is something written by a programmer. I was a programmer for 15 years, and we will actually get into programming. We're probably going to get into a little bit of Java in this class. So, when we talk about software, we have two different types of software. We have your application software and we have your system software. Your application software is the software used, such as your word processing, your spreadsheets, your payroll, anything that you use on the computer, like your games. Everybody loves playing your games. It's like the games. When you load your games on the computer, that is an application software. Now, who in here, raise your hand if you've uploaded to Windows 10? About half of y'all. Good. Well, Windows 10 is what we call a system software. A system software is an operating system like Windows, Linux. These computers that we're running in here use Linux, which they use Ubuntu off of Linux. Then we get into, okay, so you have the hardware, which is the hardware. You have the software, which is what we're going to create. That's the instructions. Pretty much the algorithm for the computer, the software. Then we go to the major operations of the program. You have three major operations, and this is something you need to really understand. You have your input. That's the data coming into the computer. You have your processing. What is actually happening? What is being done in the computer after you input data? What is being done? Is it a calculation? Is calculations happening? What is actually happening in the computer? And then you have your output. Okay, you bring your input in, you process where you do your calculations, but where does the data go, the information go when you finish? It goes out. Where? To either your monitor or to the printer. One or the other. Then you have your programming languages. Your programming languages are none other than your written instructions. There are many of them. Visual Basic, C#, C++, or Java. There's COBOL. There's Algol. There's many different type of languages that are out there. Now, we're going to talk about two different errors when we're talking about programming in this class. Two different processing errors. The two errors is either going to be your syntax error or your logical error. Right now we're keying on the syntax error. Okay, here in your English class, when you write a paper and you turn your paper in, what are they grading for? Good, you said grammatical error? That is correct. Grammatical error is what they grade for. Well, think of syntax as a grammatical error for the computer language. It's checking for your syntax, making sure you have no misspelled words, no missing punctuation, any of that type of stuff. And you cannot run a program unless it is syntax free. Okay, so you run the program. Where does all this stuff go when you're running the program? It goes into what we call memory. Memory, you have your random access memory, which is your volatile. Volatile is memory that you lose when you power the computer off. Anybody in here ever been typing a document and they shut it off, and when they come back, their document is still there? That's because your document was actually saved in non-volatile memory. And that right there is permanent storage, which means it's out there and it doesn't disappear. But your volatile is the memory that totally wipes itself clean and starts from scratch. Okay, so we have talked about programming as far as the written instructions. We talked about algorithm that we use. We talked about syntax errors, the errors that takes for your compiler. Oh, compiler. What is a compiler? Well, you create your program. How does the computer understand where we're going? How does the computer understand what we're going to do? Well, you have to translate what you wrote into a form that the computer understands. How do you translate? You use a compiler. What do you do with the compiler? The compiler, it translates your source code, what you wrote, into what we call a machine language. Remember what, earlier on this year I talked about binary code, or machine language is like binary code and the computer only understands what? Yes, ones and zeros. Well, ones and zeros is what we're transferring the code into. And then the compiler is also going to what? Check for syntax errors. So the compiler is, as it's translating your code into a code the computer understands, it is also checking for syntax errors. If it's compiled free, and it's free of errors, free of syntax, then it goes to what we call the execution of the program. That's when you can actually run the program. This is when we actually will check for what we call logic errors. What are logic errors? Okay, we talked about syntax errors. Syntax errors are grammatical type errors. Computer doesn't run if it has a syntax error. Now, a computer will run if it has a logic error. But what is a logic error? Okay, we have robots in this class that I have created. Well, actually, my robotic students have created. Say if we wrote the program and we're using Java base to write the programs for those robots, and we want the robot to move forward. But when we actually click the code, it moves backward. Okay, we want it to go forward, but it's actually moving backward. Well, what happened? That's a logic error, because we actually did something in the code incorrectly to make the computer move in the wrong direction, the robot move in the wrong direction. What about you write a program to add two numbers, but instead, when you put the two numbers in there, they subtract? What's an issue? What is the issue there? Yes, that was a logic error. A logic error is where they actually change the sign when you're writing a code. And that's a logic error. A logic error is something that usually is harder to find than a syntax error, because the logic error you have to actually go in and search for yourself. Syntax errors usually pop up and it tells you exactly the line where the errors are located. When we're talking though about syntax logic errors, one thing we have to realize is variables. What are variables? Variables are the actual placeholder. Think of algebra. You're in algebra. What is a variable in algebra? Yes, Zach. A variable in algebra is the actual, like the x or the y, where you do not know what the values are, but they're placeholders. Same thing in programming. Variable does not change. The value can change within the program, but the variable name does not change throughout the program. Here's a calculation one. Input, my number, set my number equals my number times 2, output my answer. My answer and my number are variables. Remember, variables are placeholders, kind of like in your algebra. My number is a number that you're going to key into the computer. What does this program do? This right here is doubling the number. It's multiplying by 2. So you have your input, you have your processing, and you have your output. All this in order to create the program that's going to actually work out there. First thing you have to do is understand. You have to understand what is the problem. And that right there could be where you actually sit down with the user. Who are you writing the program for? Who is the end user of the program? The person that's actually going to utilize or use the program you wrote. Sit down with them. Find out exactly what it is they want. What it is the program is supposed to accomplish. What is supposed to happen when you write the program. That's when you get all the inputs, all the outputs, everything that they're looking for. Do they want calculations? What do they want? What is it that they're looking for? Is it just a search? What is it they're looking for? This is when you actually get a list and you list them all out of exactly what the user wants. Then you go to where we plan it. Plan it, and we'll talk about that later. Planning is when you actually start kind of doing pre-documentation. And like I said, algorithm led into this. Why? Because algorithm is going to be the first thing you write when you're creating the program. You want to write an algorithm. Once you write that algorithm, you want to make sure that it follows the logic that you need. And that could be a flowchart. Now, an algorithm turns into what we call a pseudocode. Because an algorithm is no more than like a pseudocode. A pseudocode is an English-like representation of your step-by-step procedure. And using a pseudocode, you can take a pseudocode and write your code based off your pseudocode. So, we understand, we plan, we already have the program written out as far as the logic on a piece of paper, either a flowchart, which is a graphical representation, or a step-by-step English representation, which is pseudocode. Then we're going to write the code. We're going to take exactly what we did and create code and write it into a editor, which is like an IDE editor, the program. Compile what you wrote. When you compile, that's when it's actually translating the code that you wrote into a compiled language. Machine language. That machine language is ones and zeros. That's also when it also checks for what? Yes, syntax errors. So, syntax errors, if it has syntax errors, do we continue? No. We go back up and we either go to understand or plan, either one of those, to find out exactly what it was and go down and check to see what needs to be done, translate it, and keep doing that until we know exactly what errors we fix and get them fixed. Once we translate the code and it is error-free, then we can go and test the program. Testing the program is when we actually find the logic errors. Logic errors do not come in your translation. Translation is your syntax errors. Testing is when we actually have the logic errors. So we're testing the program. That's when we test input. We test output. We make sure that everything that we understood up here on the problem and we documented is happening in test. If the test is not producing exactly what the user was expecting it to produce, then we have a logic error. And we have to go back up to where we try to understand the problem. It could be try to go back to the user, find out exactly, get more specifics. Or it could be that we didn't plan correctly from where we understood. That is where we keep running till we know exactly we have everything that in that program set, ready to go into production. Once we have met everything and the end user is happy with our results, because when you're testing, you're also showing the end user, the person using it, your results. So the end user is happy, everything looks good. It's kind of like, okay, Windows 10 just came out. Does anyone here know what a beta tester is? Okay, a beta tester is a person who tests the code before it actually goes out to production. So for Windows 10, we had a group of users that was out there testing the code before it actually went into the general population. So they were testing it to make sure that it was error-free. There were no logics. That's the testing part. Once it was free and they knew that they had a code that was running the way it should, then they went to put it into production. And production is where they sent it out for a link that we got that we could actually update or upgrade to Windows 10. Same thing here. You test a program, you put it in production. You're putting it into a place where the user, the end user, could use it. Now, I work for corporations. So when I create a program, I actually put out there for the general population to use, or other end users of other companies to use, and that's when you're putting it out into production population. But that's not the end. That's not where we stop. As a programmer, we're years maintaining the program, keeping it up to date. That could be keeping our documentation up to date. Year 2000, has everyone heard of the Y2K? Y2K, that was a big year for me. I had to do a conversion of a program to maintain it to the Y2K standards, which meant that when when the year 2000 came, that program would have died and would not have worked anymore. Why? Because when they wrote the program with a 2-digit year and had everything based off of 1900. Well, when the year 2000 came, then all the calculations or whatever based on the year 2000, the 20 was not there. If you put 00, it would have said 1900. Your calculations would have been off, and we would have had a lot of calculations off with what I was using, with what the company was using. So that was a maintenance where we had to maintain the program. We had to correct it so that the error was fixed. What are the two major components of a computer system? I cover that. Anyone? Two major components. Hardware and software. Thank you. What are the three basic operations I talked about? It goes from here.
Input, process,
Yes. What is the most important phase in creating a program to solve a problem? What is the very top thing? What's the first thing you have to do before you can actually go and get the program done? You have to what is the very first thing?
explain the logic.
What was the very first thing?
Write the code.
Who said that? Understand the problem. You have to understand what you're trying to program before you can actually do it. And the last question. A computer program must be free of what type of errors before you can execute it?
Syntax errors.
Syntax errors. Good job.